Hi, welcome to the series Learn AI from Scratch. My name is Satish Karangula. In this video, we will be talking about artificial intelligence, machine learning, deep learning, and generative AI. My idea is not to bore you with these definitions, but give you a background about their evolution and discuss the correlation between them and what are the types in them, what problems they are solving. This video is the foundation for our upcoming lectures. Watch it completely to understand what is solving what problems. So let's start with artificial intelligence. This is the very broad term used to describe any system which is performing tasks with a human-like intelligence. For example, self-driving cars, chatbots like GPTs, image processing in medical field, and music composition with AI. All these are examples of AI. To talk about their evolution, this study started a couple of decades back. In the olden days, they used to build the intelligent systems based on a huge rule set. For example, huge if-else conditions like this. If it is yes, go here. If it is no, then go here. Then if it is yes, go here. If it is no, go here. Like this, it will reach particular point and then that will be the outcome of that problem. And one such example is mycin. So it was developed in early 1970s at Stanford University. What it will do is, it will identify a bacteria causing severe infections based on the symptoms and also suggest the dosage of antibiotics based on patient body weight. And this was developed based on a knowledge base of 600 rules, meaning there were 600 this kind of rules were there. So based on that, they'll see if the symptom is there, yes, then go here, and then another symptom, no, then go here, then another symptom, go here, and finally they'll find what bacteria is causing this problem. But there is a problem with this approach. Here, who is creating the rules? Human is creating the rules. It took 5 to 6 years to build this kind of a system. But think about current situation, the number of users we have, the amount of data we have. Do you think it is possible to create these manual rules? And if at all we dare to do it with the huge manual efforts, and do you think it will sustain? Tomorrow new use case will come and we need to recalculate these rules again. So it is almost impossible to create these rules. Instead, we need machines to build these rules. That is where we are interested in. Good. So we need machines to create these rule set. But how does they create them? They create them using algorithms. Let me give you one silly example. Let's assume you want to create some dish, maybe some biryani. How do you prepare them? You look for a recipe. Recipe is nothing but a sequence of steps, like you put a pot and then put some oil, then put this, put that. Then at the end, you will get a dish, right? Similarly, algorithm is also a sequence of steps. By going through, we will get a final rule set. But assume you open a YouTube and type recipe. You will get a biryani recipe, you will get a coffee recipe, you will get a pizza recipe, and several other recipes, right? So you need to choose which one you want. So you decided that you want to go with a biryani recipe. And even for that biryani category, there are several recipes over there. One might be cooking slow and the taste will be good. One might be cooking faster, but taste might not be good. One might be optimal between the cooking time and the taste. Similarly, algorithms available for several categories. Within the category, there are so many options are there. So we don't have to reinvent the wheel and create these algorithms. There are several mathematicians and data scientists already created these algorithms. Our job is to just use them and solve our problems. The machine learning is broadly classified into two. One is a supervised learning, the other one is unsupervised learning. Let me explain you with one example. Let's assume you have a friend who is expert in car. You want to buy a pre-owned car and ask him for an opinion. Then he will ask you a couple of questions like what is the brand of the car, what is the age of the car, and maybe how many miles it ran, etc. Based on that, he might give you a price. So here, these are the input parameters and these are the output parameters. The input parameters we call it as a x and the output parameter we call it as a y. So let's assume the same problem we want the machine to be solved. So what we will do, we will train the machine learning model with this data. That means we'll give some input data and respective y variable and another x variable, then another y variable, and so on. Now we will ask our model to predict the y variable based on the input x variables. Let me give you another example. The bank want to know whether their customer will default the loan or not. Let's assume the customer data will be like age of the customer, and then salary of the customer, and his family size, and then the output is like whether he will default the loan or not. So here the input will be these are nothing but a x variable, and output will be whether it will be default or not. If you notice here, this y is a numerical and this y is a categorical, meaning this y will predict the some number, let's say like a 1 million or 1.5 million, something like this. And here it will detect whether yes or no. So if you have both x and y variables in the training data, it is called as a supervised learning. Within the supervised learning, if the y is numerical, then it is called a regression problem. And if the y is categorical, then it is a classification problem. Let's assume you don't have this y, then it is an unsupervised learning. Let me go back to our diagram and show you. I hope this diagram is making more sense now. If we are having both x and y, then it is a supervised learning. And if the y is a numerical, it is a regression problem. And if the y is a categorical, then it is a classification problem. If you have only x, then that is a unsupervised learning. Let me give some example for unsupervised learning so that you will understand better. Let's assume you created a food delivery app and you ran for 1 to 2 years without any problem, and you started noticing the customers are leaving the platform. Then you need to understand what kind of customers are leaving it. Let's assume there are some loyal customers. Whether you give promotions or not, they will be with the platform. Maybe there are some other disloyal customers. They will be with the platform only if you give some discounts. So if you can divide these customers into these two categories, then maybe you can focus more on these customers by giving some coupon codes like a 30% off or something. And maybe for them, since they're already with the platform, maybe only some 10% or something. Even maybe you can cut off this 10% and give more frequent coupons to these customers so that they will retain with the platform. So this is called as clustering. That means you will be creating group of customers into different clusters, and then you will study the characteristics of each these clusters, and then you will provide your coupons or promotion based on these clusters. So this is nothing but a clustering. So in the previous example, I'd show you about input variables, right? They are called as features. So here we have 3 features and the output is called as a target. So we have 3 features and 1 target. In this example, I have given you only 3 features, but the real life use cases will have thousands of features. Let's assume you have 1000 features, but in order to process all these 1000 features, it will take a lot of computational power. So instead, what you can do is you can reduce these 1000 features into maybe 100 important features. This process is nothing but dimensionality reduction. So if you go back to the previous diagram, dividing the users into multiple groups is called as a cluster, and reducing the number of features or input parameters is called as a dimensionality reduction. Good. So we have some relational data and we created a relation between them using machine learning algorithms. But every problem is not that simple. Let's assume image processing, speech processing, or language processing. It requires more complex patterns to be uncovered. That's where the deep learning come into pictures. It works based on a multi-layer neural network architecture. Let me explain you what is this neural network. If you see this, the top one is a biological neuron, where it is having these spoke-like structures in the beginning. Their job is to gather the information from other neurons. The nucleus will process them, and these axon terminals will pass it to the another neurons. And here, the artificial neuron is also work in a similar fashion. It will take some inputs, and then it will process that information and it will pass on the output. Deep learning is a very vast subject. We will discuss in depth in upcoming videos, but let me explain some use cases. For example, natural language processing, image processing, these are comes under deep learning. So the generative AI is a subset of deep learning where we will be using some specialized algorithms and techniques and train the models with tons and tons of data, and then we will be using it for creation of completely new things. I know there is too much theory in this session, but these are the fundamentals, and my main idea is to build the knowledge from the scratch. In the upcoming lectures, I'll definitely show you the practicals, like we will be building the models, training them, and using them. I hope you are excited to learn furthermore. So for that, all you need to do is subscribe to the channel and stay tuned. Thank you.